Hello everyone. In this video, I'm going to discuss Cahn Ingold Prelog sequence rules. Commonly, these are abbreviated as CIP rules. Cahn, Ingold, Prelog, they are scientist names. Most importantly, in this video, we are going to talk about what are these sequence rules. Totally, we will be discussing 5 rules. We will complete these rules under 5 steps. Where do we use these rules? How these rules are useful? For example, there are two groups attached to a carbon atom. One is A, another one is B. The two groups attached to one carbon atom are A and B, and you want to give the priority to A and B as 1 and 2. Higher priority group, lower priority group. If you want to give priority to the groups or atoms attached to a particular carbon, we use these CIP rules. Otherwise, there is a carbon atom, sp3 hybridized carbon, tetrahedral carbon. There are 4 groups or atoms attached to that particular carbon. They are A, B, D, E. Your intention is giving priority to these 4 groups. In that situation also, we use CIP rules. And particularly in 2 subtopics, we use these rules. One is EZ configuration of geometrical isomers, RS configuration of optical isomers. In these 2 subtopics, EZ configuration and RS configuration, totally this configuration is based on CIP rules. We give priority based on CIP rules, then we'll decide EZ configuration and RS configuration, that is the application. What is the basis for these rules? These rules are based on atomic number. Only in case of isotopes, since they have same atomic number, we consider mass number. So here nothing to do with the IUPAC sequence rule here, like a carboxylic acid, ester, not like that. We don't take IUPAC sequence rule because most of the students generally they commit mistake because they are applying IUPAC sequence rules, but nothing to do with IUPAC sequence rule. Here totally it is based on atomic number. Now let us discuss the rules in 5 steps with a clear example. Here, of the 2 atoms or groups attached to one carbon, for example, if you have a carbon, it is attached to chlorine and bromine. Otherwise, carbon attached to hydrogen and fluorine. Or you can also take in the third example, carbon attached to NO2 and OH. Even if you see the last example, carbon attached to CH3 and NH2. Of the 2 atoms or groups attached to one carbon, the one with the higher atomic number, will get first priority, that is high priority. In chlorine and bromine, which receives more priority, high priority, least number. Hydrogen and fluorine, NO2 and OH, CH3 and NH2. So this is the first rule. Completely we are depending on atomic number. In case of chlorine and bromine, no doubt bromine atomic number is 35, chlorine atomic number is 17. Bromine gets the first priority, chlorine gets a second priority. High priority means least number. In hydrogen and fluorine, fluorine atomic number is greater than hydrogen. Fluorine is 9, hydrogen is 1. So this will receive first priority, hydrogen will receive second priority. In case of NO2 and OH, this is the point of attachment. Here point of attachment is nitrogen. Here the point of attachment is oxygen. Oxygen atomic number is more when compared to nitrogen. Oxygen is 8, nitrogen is 7. So OH receives first priority, NO2 receives second priority. And in the last example, you can see one is CH3 and NH2. First thing is point of attachment, here carbon, and here it is nitrogen. Nitrogen atomic number is greater than carbon. Therefore, NH2 receives first priority and CH3 receives second priority. In this video, we are just understanding the rules, but in the next video, we will solve questions exclusively on CIP rules. So this is the first rule, and the second rule says if atomic number is same, if the atomic number of two atoms attached to a particular carbon, if that atomic number is same, in that situation we have to consider atomic weight. For example, hydrogen and deuterium are attached to a particular carbon. In that situation, deuterium atomic mass, that is mass number, is more than hydrogen. Therefore, deuterium receives first priority, hydrogen receives second priority. In deuterium and tritium, tritium mass number is more when compared to deuterium. Therefore, tritium receives first priority, deuterium receives second priority. You have carbon 12 isotope and carbon 13 isotope. In that situation, carbon 13 mass number is more, therefore this will receive first priority and this will receive second priority. So ultimately the combination, for example, there is a tetrahedral carbon. Here the groups or atoms attached are like this. Let me take one example randomly. And if you see carefully, here we have hydrogen, deuterium, OH, NH2, point of attachment oxygen, nitrogen. Now we have to compare oxygen, nitrogen, deuterium, hydrogen. Oxygen, nitrogen, deuterium, hydrogen. So oxygen atomic number is more, this will receive first priority, this will receive second priority. In deuterium and hydrogen, since atomic number is same, we are considering mass number. This will receive third priority and this will receive fourth priority. You may get a doubt, why are we giving the priority? Already previously I talked about that. We are going to use these CIP rules in two different subtopics. One is EZ configuration, another one is RS configuration. Let us move on to the third rule. Here, if the atoms attached to the carbon are same, CH3, CH2, CH3, carbon, carbon, even atomic weight, carbon 12, carbon 12, compare the atoms attached to them in order of decreasing priority, and decision is made at the first point of difference. Instead of reading that rule, let me explain the situation. We have a carbon atom like this. It is attached to two groups. One is CH3, another one is CH2, CH3. We have to give the priority to methyl group and ethyl group. When methyl and ethyl groups are present, what we need to do is, here the group methyl group, let me elaborate that. Let me write all the bonds to explain this. And here we have carbon, here also carbon. We need to compare the atoms attached to them, means hydrogens. In the decreasing priority, what is that decreasing priority? Here point of attachment carbon carbon, atoms attached to the first atom. So here this is carbon, this is the first atom, this is second atom, this is the first atom of the group and these are second atoms, first atom and these are second atoms and these are third atoms actually. So here first atom is same, so we are considering second atoms. Whenever you are considering second atoms, whenever you are considering second atoms, their atomic numbers must be compared in decreasing order of priority. What does it mean? Here second atoms in methyl group, second atoms are hydrogens and their atomic numbers are same 1 1 1. But you will understand here in this second atoms are hydrogen hydrogen carbon, their atomic numbers must be written in decreasing order, decreasing order 6 1 1. Here we have 1 1 1, here we have 6 1 1, therefore here 1, here we have 6, so this will receive more priority when compared to this. Ethyl group receives first priority, methyl group receives second priority. Another example you can see CH2OH, isopropyl group. To avoid confusion, so here the first atom is carbon, first atom is carbon, so let me encircle that first atom, first atom. If the atoms attached to the carbon are same, compare the atoms attached to them in decreasing order of priority. Here what are the atoms attached to carbon? Hydrogen, oxygen, hydrogen. Here hydrogen, carbon, carbon. Now you need to compare the atoms attached to the first atom. That means you have to compare the second atoms in the decreasing order of their atomic number. Here in the first example we have hydrogen, oxygen, hydrogen, decreasing order of atomic number 8 1 1. In the second example isopropyl group carbon carbon hydrogen, so here that is 6 6 1. So obviously here we have 8, here we have 6 8, here we are getting the difference, therefore this will receive first priority, this will receive second priority. We are just understanding the rules, but in the next video, in the next lecture, I'll be discussing exclusively questions on CIP rules. You just understand the rule, and the next rule, the very important rule, here most of the students get confused. If the group contains a double bond or triple bond, then it is needed to perform duplication for double bond, triplication for triple bond. For example, here we have a group, that group is carbon with a double bonded oxygen. So what is meant by this? So to explain in better way, I'm taking this is the carbon and here we have C double bond O and something like hydrogen or methyl group, whatever it may be, and this is the group we are talking about, and this group has a double bond like this. So before comparing their priorities, that double bond should be duplicated, triple bond should be triplicated. So what is meant by duplication? Here double bond we have, writing that double bond into two single bonds. Here the double bond is between carbon and oxygen. So this is one bond, this is another bond you are writing. This oxygen original atom, and here this double bond is with oxygen, so we are converting double bond into two single bond, and this is phantom atom. This is not the original atom, this is original atom, this is phantom atom. Here carbon has a double bond with oxygen, we are converting double bond into two single bonds. Here this is original atom and this is a phantom atom. Oxygen is having double covalent bond, but we are writing that double covalent bond into two single bonds. This is the original atom and this is the phantom atom. You have to satisfy the valency of original atom but not phantom atom. Need not to satisfy the valency of a phantom atom. So this is called duplication. Now you have to compare the atoms. Here this is the first atom and this is the second atom. This is the second atom. Here also we have second atom. This is called duplication. Similarly, if the group contains a triple bond, we have to perform triplication. That is very clear. This triple bond should be converted into three single bonds. So this is a triple bond is with A. So here this is the original atom and these are the phantom atoms. Here you see the valency of A is 3. 1, 2, 3. And it is having triple bond with carbon. Therefore this is carbon, carbon, carbon. But this is original atom and these two are phantom atoms. So triplication, before comparing we have to go for triplication. So let me explain one example so that there will be no confusion. So C double bond OH, C double bond OOH. One is aldehyde functional group, another one is carboxylic acid functional group. And here first I am taking aldehyde functional group. So this is the point of attachment I am writing. This is carbon, hydrogen, original atom, phantom atom. So here this is carbon oxygen double bond. So here that is duplicated. So this is original atom. For that original atom we have to satisfy its valence. So that is carbon. And in case of carboxylic acid, so here this is aldehyde group. And in case of carboxylic acid, I am writing this particular group. So this is the point of attachment and this is carbon. It has OH group, you can see, and carbon oxygen double bond. So one is original atom, another one is a phantom atom. For this original atom, valency should be satisfied. Now you have to compare. This is aldehyde group, this is carboxylic acid group. You see here we have carbon, here we have carbon. If first atom is the same, then you have to consider the second atoms. Here second atom is oxygen, oxygen, hydrogen. Oxygen, oxygen, hydrogen, that is 881. And here we have oxygen, oxygen, oxygen. So that is 888. You can see the first two are same, but at here we have 8, here we have 1. Therefore, carboxylic acid gets more priority when compared to aldehyde. But I'll discuss more number of examples in the next lecture. And the last rule in CIP rules, lone pair always gets low priority compared to atom. Any atom you take, atom with the least atomic number, hydrogen and lone pair, hydrogen gets more priority. OH and lone pair, OH gets more priority. NH2 and lone pair, nitrogen, NH2 gets more priority because atomic number of that lone pair, actually there is no atom, its atomic number should be 0. So obviously atomic number is not there. Therefore, lone pair always receives second priority when compared to any atom. And these are the 5 rules of Cahn, Ingold, Prelog sequence rules. What are these rules we discussed? Where do we use these rules? Of course, I explained. And what is the basis for these rules we discussed. So this is CIP rules, very much important. In the next lecture, I will discuss the questions on CIP rules. Thank you very much.